Hello everyone, I'm glad to report our paper to you today. This work is from the School of Artificial Intelligence here at University. This report is divided into the following four parts. I will first give a summary of this paper. This paper focuses on unsupervised model adaptation. Exciting UMA methods adopt offline self-training, but it requires expert iteration. Online self-training can avoid the drawback of OST and shows potential in unsupervised domain adaptation. From the figure below, OST methods suffer from stability and adaptability in UMA. So to apply OST to UMA, we explore two reasons for this and propose two methods for these reasons. Next, I will go into details of the paper, starting with motivation for the research. UDA in semantic segmentation transfers knowledge of the source domain to the target one to improve the adaptability and the model in the target domain. However, in some sense, source domain data is often unavailable, which presents new challenges for UDA. Therefore, unsupervised model adaptation is proposed, which aims to adapt the source training model to enable the target domain without using source data. The dating UM method adopts offline self-training that adaptively updates the labels to retrain the models, but it requires expert iteration. Online self-training can avoid the drawback OST by online code in real person labels showing potential in UDA. Then OST be applied to UM sense to where this way deploy the SOTA OST models to UMA and draw the MLU score curve on the validator side as shown in Figure 1. And we can see that OST is more competitive than using UM method but suffers from stability and adaptability in UMA. So this leads to a source how to apply OST to UMA. In this paper presents a novel method. Now let's talk about the specific design of our method. Apply OST to UMA, we first explore two reasons for this stability and adaptability. That is the input to update the teacher model and the bias towards minority classes in the source training model. And based on this form, we propose a dynamic teacher update method for two-way propose a training. Talking about the two models proposed, I will give a detailed symbol definition and the flow of the original OST to facilitate the understanding of our method. Okay, generally in OST, given a student model and an unupdated teacher model, for student, two losses are used for variant, and the first is the supervised loss of the source domain. The second is the unsupervised weak to strong consistency loss of the target domain. And for teacher, its parameters as students' model updated variant. So as OST method adopts historical variant to regularize the creation of model evolution. This will avoid model degradation. Having introduced this, I now present the details of the two proposed models. Okay, the first is dynamic teacher update. In UMA, the source data is not accessible, making the student's supervision only from the weak to strong consistency loss. In that case, an important condition for evolution is that the teacher model can aggregate the involved student. Then in each update of the teacher, whether the student evolves becomes the key factor for co-evolution. So how to evaluate the evolutionary state of the student model? Exotic changes in student model performance over historical samples during an update period can reflect evolution and calculate the average gain rate GR. And we designed two forms of the evaluation function, and we plot the curves of MAU score of the teacher and GR with training as shown in Figure 3. We can see that co-evolution and GR are positively related, so it's reasonable to argue that the performance of the student or historical samples can reflect its evolutionary state. Then we can use this function to measure whether the student is involved to control update Now to introduce the second proposed module, copy-paste simply is widely used in UDA. It uses the class distribution of the sort domain to determine the minority classes and copies the sort images containing minority classes and paste them to the target. However, the inaccessible source data prevents it from being applied to UMA. Therefore, we explore a new way for copy-paste. First, we calculate the online average class score from the output of the teacher, and the low confidence classes in ACS are considered to be minorities, and we then use SS to determine the sampling rate for each class, and the sampling rate of the minority class will be greatly improved. Besides, to build reliable target candidates for copy-paste, we regard the prediction consistency of the teacher model before and after multiple iterations of evolution as reliability. After calculating the reliability for each class, we store the target images according to it and take the sample from the top C as the reliable candidates. Let me conclude by presenting the experimental results of the proposed method. We perform UMA using pre-trained models from two datasets, GTA5 and CCA, adapting them to real science, including cityscapes and BDD100K datasets. We use the training set of both real-world datasets as the target domain, and we compare our method with SOTA method, including sort-free UMA and UDA methods. And from these tables, we can see that our method both the UMA and UDA methods on each benchmark. Besides, this paper provides the population study and some sensitivity analysis. From the above results, we can see that proposed two modules are complementary, and the overall method is stable and lowers two parameters, and more detailed analysis can be found in our published paper.